Assalamualaikum and hi. I hope you have a very good day. So today we are going to talk about recent development of power monitoring system using Internet of Things, or we call it IoT. But before we do so, let me introduce my name and my teammates. My name is Aiman bin Muhammad Syukur. Next, Ahmad Nur Husaini bin Nur Hasni, Hazimi bin Azman, Khairul Azman bin Jantan, Nur Bazlan bin Muhammad Sazanuddin, and last, Roland anak kepada Jana. We are all from Faculty of Electrical and Electronic Engineering Technology of University Technical Malaysia Melaka. First of all, the introduction. Based on Patel 2016, IoT is the network physical objects, devices, instruments, vehicles, building, and other items embedded with electronics, circuits, software, sensors, and network connectivity that enable these objects to collect and exchange data.
For the next slide, we'll be focusing on the power monitoring system device. A power monitoring system device is a device that will be measured for the power consumption in order to support the energy saving activities. This is how the power monitoring system device works. Firstly, the method in order to measuring the current flow through the wires to use current transformer that will apply the principle of the transformers. The wire of the current will be measured passes through the core. The number of turns in the primary coil will be operates as the transformer, and the current that will inversely proportional to the number of turns in the secondary coil flows through the secondary coil.
My name is Husaini. Okay, I will explain starting from slide number 5. So in this slide, I will explain a block diagram, a simple block diagram that shows the implementation of power monitoring system using IoT. So in this slide, we have approximately 7 important components. We have energy meter, current transformer, voltage regulator, microcontroller, Wi-Fi module, and power supply. So the power supply will supply a single phase power, and then will go through a voltage regulator. Before that, rectifier to convert the AC power to DC power to supply the power to Wi-Fi module and microcontroller. So the most important component here is energy meter. The energy meter will record the value of power, current, and voltage, and the data will be sent to the microcontroller. Microcontroller here can be any types of microcontroller, such as Raspberry Pi, Arduino, and any supported microcontroller that can link this data with IoT device such as Wi-Fi module here. So all the communication and the process will be carried out in the microcontroller. Okay, in this sample project, I have obtained this sample project based on the previous researchers that have been done this project. Okay, in this project, they use power supply, single phase power supply, also to supply it to the load, and the power supply also will be converted into DC power to supply it to Arduino. In this case, Arduino microcontroller. Okay, in this sample project, they applied current transformer with a combination of PZEM 004T V3. Okay, This combination current transformer and PZEM is to measure the voltage, the current, and power along the power line on the above design. So the current transformer here, the ring here, is located along the power line here that will be supplied to the load in the orange color. So when there is a current pass through the current transformer, it will capture or record the value of current power inside this PZEM. Okay, the data inside the PZEM will then be sent to the microcontroller and will be processed. Okay, in this microcontroller, it will communicate with a GSM module to send a message about the data and the consumption of electrical usage, such as power usage, electrical current usage, and some setting or code can be also used to shows the bills to the user. Okay, GSM module recently can send in the form of message, such as message that we receive from KKM during PKP.
Okay, for this slide, TMB Smart Meter. The main function of the TMB Smart Meter is to read of your daily energy usage and provide more precise bill. TMB Smart Meter also send the data by using a frequency band 2.4 GHz as used in Wi-Fi and Bluetooth. Okay, for this slide, as we can see, a picture of a TMB Smart Meter that we can find easily on our outside house. And the second picture, TMB energy usage, that we can simply find this app on the Play Store or App Store to check our daily usage or monthly usage.
Monitoring and live reporting of solar cell energy usage and output. The Proximometer from Develco product is designed to integrate a household solar power module into a smart home and smart monitoring solution. Put simply, it allows your customer to monitor their energy production and consumption. Active prosumers are now offered the opportunity to access real-time measurement of the percentage of energy consumed coming from their own photovoltaic. The prosumer is a triple three-phase meter. It measures production and consumption of power on all three levels: the solar cell module, the total household, and the connected grid. This allows the user to get a live feed of how much electricity is produced by the solar module and compare it to the total consumption of the household as well as to the grid activity in general. The proximometer also offers the flexibility of using it as two three-phase meters for separate groups in a building. The proximometer can set up notification regarding energy, power, voltage and current per phase or in a total.
Power monitoring with IoT. Sense home energy meter by Sense. Function is to detect devices by identifying unique electrical signal, monitoring current devices that still running, providing timeline of home activity, power meter that show wattage chart for the whole activity in real time, signal processing 1 MHz sampling rate to 1 GHz ARM processor, and the last one, data sent with Wi-Fi Bluetooth smart bandwidth. So this is the figure of Sense and Sense app interface. We can control sensor using Sense app interface via Wi-Fi Bluetooth smart bandwidth.
So this is our second last slide for our presentation.
There are 5 reasons that why we need to consider power monitoring system. Firstly, if you had an experience in your facility about the premature failure, which is if you had something wrong in your equipment before then an expected or predicted failure that will be happen in your equipment. Second is about tripping or unexplained resetting of the control device. Then if reliable clean power is critical to facility operation or personal safety. Next, if you wish to have an ultimate emergency power supply system, which is EPSS, will be reporting for the compliance purpose. Lastly, if you want to have the allocate cost with a complicated electric rate schedule. So that is about the reason why we need to consider the power monitoring system.
Last but not least, the conclusion of this topic are: first, IoT has been developed rapidly and a large number of enabling technologies have been proposed. Second, it will become a new trending in terms of internet usage. Third, many new technologies will emerge in the upcoming years to a whole new level of a smart world. Fourth, it will provide a better lifestyle to mankind. That's all from us.